Let's start. Let's start by doing the actual what's it called? Manger.
The Sierpinski's carpet.
Sierpinski's carpet. Sorry. Yeah. So you start with a square. You chop each side into 3, so you get 9 squares, and then you. I guess I'll fill in to indicate removing the middle one.
Yep, and then you chop the remaining.
Well, if we started out with an area 1,
This would
what's our area now?
Now 8/9.
Okay. How come? Why is it 8/9?
Because you have 9 little squares of equal area. Then you remove one of them.
Okay, so we go from 1 to 8/9. And then can you tell me what happens next?
So then you divide each of these little squares into 9 pieces.
The same way. I'll
Yep.
just do it for one of them.
And then you take out that middle square.
That middle square. Okay, and I'll just fill that in. So I'm removing that. So what happens to the area of our shape at the second stage?
Well, I think you're removing 8/9 of a little cube. Because you're removing 8 of these little centers. A little square. And then you have 9 little pieces here.
Okay.
So you're removing 8/9 of one of these.
Oh, I see what you're saying. These 1, 2, 3, 4, 5, 6, 7, 8. I'm removing 8/9 of the of one square. Okay, so that's a very interesting way of looking at it.
So wouldn't that be? That'd be 8/9. You're removing 8/9 of 1/9.
Okay.
So that would be 8/81.
8/81 is how much you're removing.
And you have currently. You have 72/81.
Is what you have now?
Is what you had before.
Is what you had before. Okay.
Yeah, right. When you remove this.
Okay.
So you'd have 72 minus 8, which is 64/81.
Okay.
Left.
Oh, that's a great calculation. So now I went from 1 to 8/9 to 64/81.
Now I think I can see an area where I think a formula where you get from the next stage.
Okay.
Because 8 squared is 64, 9 squared is 81.
Okay.
So maybe you just maybe say cubed now, which is
So maybe you keep multiplying by 8/9 every time.
Yeah.
So do you know what 8 cubed is?
8 cubed. 1024. I think it's 512.
Yeah. 8 cubed would be 64 times 8. So what is 60 times 8?
60 times 8 is 480.
480. So do you think 64 times 8 would be 1024?
No.
No.
So, but it has to be a power of 2.
Yeah.
So, and the closest one is 512.
512. Okay. Do you happen to know what 9 cubed is?
9 cubed is 729.
729.
512 is 729.
Okay. Now here's the interesting question. Why are we multiplying by 8/9 every time? In effect, what that's saying is every step we're removing 1/9 of the area.
Well,
Can you see why
I
we're?
think because you're chopping everything into 9s, and then you're removing from all those 9s. You're removing 1 out of every 9.
Yeah. So there you go.
So if you did this forever, wouldn't the total area be 8 to the infinity over 9 to the infinity?
That's right.
Which is infinity over... 8 to the infinity is infinity.
Yeah. So we have to be a little bit careful about how we think about
Infinity over
that.
infinity.
But maybe we can see a pattern. Which number do you think is bigger?
Well,
8/9 or 64/81?
I think this 8/9 is bigger.
Okay. Why?
Because the difference between the numbers, like 8, the difference between 8 and 9 is less than the difference between 8 squared and 9 squared.
Okay.
And also 8/9 is 72/81.
Okay. Yeah. So,
And then they keep sort of spreading farther apart.
yeah.
And you're also taking out area. And so this number would be bigger because you're taking out area.
Oh, great observation. Great observation. And so if we actually did this calculations, which I don't want to get into the calculations. If we did the calculations, we would see, just like you said, we'd be getting 8/9 to the nth power, and we would see that this goes to 0 as n gets bigger and bigger. And by that I mean it just gets closer and closer to 0. It never is actually 0.
When n is infinity, it is 0. But n will never be infinity.
Yeah, I don't have an infinity button on my calculator. But you can sort of see what's happening. Now let's talk about the new thing they did in the movie.
Okay.